So this is box 1B, and we're working on factoring. So remember that factoring is just the opposite of expanding. That's all factoring is. You can always check to see if you've done a factoring operation correctly by expanding it back out and see if you've done it. Okay. The first type of factoring we were going to learn in grade 12 is called sum and difference of cubes. Now you should be, and hopefully everybody's familiar with difference of squares. So remember, difference of squares is when you have a binomial and you have two perfect squares and it has to have a subtraction sign in the middle. Okay? Sum and difference of cubes is you're working with cubed numbers instead of perfect squares. So what's in a perfect cube? Anybody give me an example of a number that's a perfect cube? Yeah, 27, right? 27 is a perfect cube because, right, exactly, because 3 times itself, 3 times gives you 27. So the perfect cubes, just like perfect squares, you should be able to recognize. So the first one is 1 because the cube root of 1 is 1. The next one is 8 because 2 times 2 times 2 is 8. The next one is what Ian says, 27. And then 64. And then 125. And then 216. And then they go up. Okay? So those numbers are perfect cubes. So if I ask for the cube root of 125, that answers 5 because 5 times 5 times 5 is 125. If I ask for the cube root of 100, that's not a nice number, that's a decimal. Okay? So I'm going to show you in general, and then I'm going to show you how to do it in practice. Okay, so it's a little bit different in the way, and you'll notice I do this a lot in my lessons, is I'll do it a different way in which the guide is teaching. One, it's the way that I prefer to teach it, and for you guys to learn it. You can do it either way, okay? And sometimes it's a good idea to have 2 different ways of doing something. Okay, so in general, a perfect cube is a number that has a perfect cube root, right? What's the cubed root of a cube? Yeah, a, right? Because a times a times a is a. So a cubed is a perfect cube. B cubed is also a perfect cube. Right? And I'm going to put a minus sign. This is factorable. We can factor this expression. Unlike difference of squares, you can also do the sum of cubes. They're both factorable. Okay? With squares, it has to have a negative sign in the middle. If it has a plus sign, you can't factor it. Not true with cubes. Okay, so this is how you're going to factor. And factoring is just like having a Rolodex, or I don't know, you guys know what a Rolodex is? No. Okay, let me get into the new century. It's like having an iPhone and having your contacts, and you know how they're all listed there, right? That's what factoring is. It's just identifying what it is and then doing it. Okay? So I identify this as being a difference of cubes. Now I'm looking for my iPhone, the part where how do I factor difference of cubes? Okay, this is what I do. I take the cubed root of the first term, which is a. I take the cubed root of the second term and include the negative with it. So negative b cubed. What's the cubed root of negative b cubed? Yeah, negative b. So that's how you get the first bracket. Now you can even ignore the question, and you're just going to work with this first bracket to get the next bracket. Square the first term. Multiply the 2 terms together and change the sign. And square the last term. This is how you factor difference of cubes. This is how you factor sum of cubes. Cubed root of the first term, cubed root of the second term, square the first term, multiply the terms together and change the sign, square the last term. So they're done the exact same way, right? The only difference is, and this will always happen, the sign here and the sign in the middle will always be different. Here's a plus sign. Okay? Okay, so now let's just practice this. Okay, so again, factoring is just recognizing what type of factoring you have to do and then executing it. So I get a nice factoring question, and it's not going to say factor this by difference of cubes. It's going to say factor, and you have to identify what type of factoring it is. Okay? Okay, so you're looking at this, right? It's not a trinomial. You're going through your whole factoring tree. You're like, first thing you look for is a common factor. There's nothing common about it. Next thing you look at is the number of terms. If there's two terms, the only thing it can be is difference of cubes, sum of cubes, or difference of squares. So now you look at the two numbers. This is a perfect cube, this is a perfect cube. Okay, so you identify it as being a difference of two cubes. What's the cube root of the first term? Yep. Right. What's the cube of the next one, Dave? What type of two? Negative two. Okay. So that's your first bracket. Your next bracket comes from the first bracket. Take the first term, which is x, and square it. Multiply the two terms together and change the sign, and square the last term. And that's all there is to factoring a difference of cubes. The trinomial, right? Trinomial, three terms. This, you can never, ever factor that. Okay? So this is always just going to be one answer question. Okay. So we'll try a little bit of a harder one. But again, the concept's exactly the same. So just like anything in life, you can watch me do this a million times. You're not going to get better at it unless you try it. So try it, and then we'll take it up together in 30 seconds or so. And everybody want to tell me what the first bracket would be? Yeah. Awesome. You want to continue on? Okay. Okay, just stop you there. Okay. So it's 3x and the whole thing is squared. So you have to square the x plus the 3 as well. Okay, so it's like 3x times 3x, which would give you 9x squared. You know what I mean? Yeah. And then the next term? Right. That's a y, right? So then 3 times 4 is 12. So it would be negative 12xy. And then the last one, again, square the whole 4y. So, right. So again, factoring, recognize what type you're doing, execute it. Okay? So the concept's the same, whether you have something like this, or even if it gets a little bit harder. So let's do a little bit of a harder one. Try this one. Again, try it, and then we'll take it out. So again, this is new material, like 110%. You're going to get a question like this in your text. Like 110%, right? It always amazes me when somebody leaves this question blank. Like, I'm not trying to trick you, right? I'm trying to teach it to you, and then I want you to show me that you've learned it, right? So you're going to be looking for, in your factoring questions, to identify sum and difference of cubes. So this is a difference of cubes because what times what times what gives me 1 over 8? Right. what times what gives me negative y to the 6th. Yeah. All right, square. Awesome. And just check it. Always, like, it just takes a second to make sure you've done this correctly. Multiply this out 3 times in your head, make sure you get that. Multiply this out 3 times in your head, make sure you get that. If you get this first bracket wrong, the rest of it's going to be wrong, right? So just take a minute, make sure that you've done that correctly. This sign here and this sign is always going to match. I don't know if you've noticed that. Plus and plus, minus and minus. Okay, so now you're saying, okay, what I need to do now is square the first term. So square the first term, 1/2 times 1/2 is 1/4. Multiply the two terms together and change the sign. So it becomes plus y squared over 2, and then square the last term. So y squared times y squared is y to the 4th. Yep. Yes. So you're like you were saying. Yeah, totally. It's a different way of writing, right? Okay. Okay, so just to really beat this home, try this one. Anybody prepared to tell me what the first bracket would be? Brennan. Yep. Awesome. Is there anybody unsure where that bracket came from? Pardon? Oh yeah. Sorry. Add it, right? This? Yeah. I added it after. Okay, thank you. Okay, so now is anybody unsure where that came from? Does that all make sense? Okay, so the next part is just a matter of saying, okay, now all I have to do is square this first term. So x cubed times x cubed is x to the 6th. 5 squared is 25. Multiply the two terms together and change the sign. So negative 2x cubed over 5y squared. And then square the last term. 2 times 2 is 4, y squared times y squared is y to the 4th, and then that's it. So no matter how ugly these questions get with fractions and different exponents on the x's and the y's, concept's the same. Make sense? Okay. So the next thing we're going to do is some common factoring, but we're going to make it complex. So complex common factoring. So I'm going to show you, again, remind you how to common factor, and then we're going to use the same concept for harder questions. Okay, so example factor. The following. X to the power 6 plus x to the power 4 plus 2x to the power 2. So if I ask you to common factor this, right, you're looking for the biggest common factor that goes into x to the 6, that also goes in x to the 4, that also goes into 2x squared. What would that common factor be? Yeah, x squared. Okay. So really what you're doing is you're identifying the variable and you're taking out the smallest exponent, because that'll go into all of them, the smallest one. Make sense? So if I do that, right, x squared times what will give me x to the power 6? Well, remember when you multiply powers at the same base, you add the exponents. So you just want to make these guys add to 6. Make sense? It just takes a second to make sure you've done it correctly. And then x squared, and then 2. Exact same question, well, not exactly the same question, the exact same concept. But now I'm going to throw in negative exponents. So the concept's exactly the same. The common factor is the same variable with the smallest exponent. So what would the common factor be in this question? Yeah? Right. X to the negative 6, right? So x is the common variable. Negative 6 is the smallest exponent. Okay. Now to fill in your remaining term, you say to yourself, x to the negative 6 times what will give me x to the negative 6? What would that be? Yep. What? X to the negative 6 times something will give me x to the negative 4. So now you're dealing with adding power to the same base. So basically you want an exponent that when you add it to negative 6, you're going to get negative 4. Right. And then the last one. Right. And again, it just takes a second to make sure you've done it correctly. Multiply this back in your head and make sure you get that times that is that times that is that. Okay. So the concept applies for any single exponent. It doesn't matter if they're rational exponents. Every single time you are complex common factoring, that involves negative exponents and rational exponents, your remaining term should never ever have negative exponents in it if you've done it correctly. Okay, concept's exactly the same, but now I threw in some coefficients, just to remind you that you still have to include the coefficients, right? Because 2, 8, and 4 are all divisible by 2, so 2 is a common factor. And then this has an x, this has an x, this has an x. So I'm going to take out x with the smallest number, which in this case, what's the smallest number? Yeah. Right. That's right. So now we're ready for what's left of the side. So I want to take 2x to the negative 5 over 2, multiply it by a term so that I get 2x to the negative 3 over 2. Well, 2 times 1 is 2, and x to the power of what will give me that? So you want to add negative 5 over 2 to something so you get negative 3 over 2. Okay? Right, it's just x, right? So really what you're doing there is you have 2 over 2, right? Because negative 5 over 2 plus 2 over 2, you add negative 5 to 2, you get negative 3, and that stays the same. But but 2 over 2 becomes 1, and x to the 1 would just be x. Make sense? Okay. So that all goes down to 1, and you don't have to put exponent 1 in, it's understood to be there. Okay, the next one. Okay. 4 x to the power of 3. So I'm going to change 3 to 6 over 2 again, so people can see it. Okay. So negative 5 plus 6 is 1, and common denominator 2. But of course, you wouldn't leave it as 6 over 2. You would leave it as 3. And also 2 times 4 is 8. And the last one, might as well finish it off. 2. So 2 times 2 is 4. X to the negative 5 over 2 is x to the negative 5. Make sense? Okay. So now we're going to start to involve common binomials. Okay? So remember that when you are doing hard-type trinomials, when you're solving it, if you do them by decomposition, depending on who you had in grade 11, they taught you different ways of doing hard-type trinomials. But you may end up with something like this. 2x, x minus 7, minus 3, x minus 7. So this expression has two terms, right? It has the first term here, and it has the second term here. So you look and you say, okay, the red term and the green term both have a bracket x minus 7. So I'm common factoring that x minus 7 out. So I've taken it out of here, I've taken it out of here, and then I write down what I'm left with. Make sense? So we're going to use that concept for harder type questions. So let's try this one. So same concept as the one above. I have my first term, then I have a plus sign, so that's what separates my terms, and I have my second term. I'm going to look at the red term and the green term, and I'm going to figure out what's common to both of them. So what's common to the red and the green term? Anything the same, Brennan? Okay, so just stop there for a sec, if you don't mind. So x minus 3, and again, just like we learned over here, you take out the smallest exponent. This has 4, this has 3. I have to take out the smallest one. And what else, sorry? Right. X plus 1 cubed. Does that make sense? Okay. So now I'm going to write down what's left after I've common factored out these two brackets. Okay. Now what I like to do is actually cross things out. If you're going to do that on a test especially, make sure I can still read it, okay, because I can't mark this for talk. So what I say is, okay, I'm looking at the red term here. Out of the red term, I've taken out x minus 3 to the 3. There was 4 of them there. How many would I be left over if I take out 3 of them? There was 4. Yep, 1. So I cross out that, I'm left with 1. X plus 1 to the 3, I've taken out. There was x plus 1 to 3 of them. How many am I left with? None, right? So the whole thing is gone. So the only thing I'm left with from the red term is what? Yep. Right, and that's what's going to go here. But you can put it in brackets if you want. You don't have to. I'll put it in brackets just. Okay, so I've done the red term. Now I'm going to do the green term. So now I need to write down my plus sign. Plus. Okay. My green term has a 3 in it. I didn't do anything with that 3 because it's not a common factor. So what should I do with that 3? Yep. Yeah. Leave it there. Right? It didn't go anywhere. It wasn't part of the common factor, so I still have to account for it. It still has to be there. Okay. X minus 3 to the 3. X minus 3 to the 3. I've taken all of those guys out. They're done. X plus 1 to the 3. There was 4 of them. I'm left with 1 of them. What do you think my next step is now? Right. Yeah, but expand in 3, right? Right, exactly. So just expand and then collect like terms inside of that bracket and you're done. And if you are able to expand without showing your work, that's fine. But if you're going to make little mistakes because of that, make sure you show everything. Okay? So if you can go 3 times x is 3x, added to 1x is 4x. 3 times 1 is 3, minus 3 is 0. So that would be your final simplified. Okay. Exact same concept. I'd like everybody to try this one. You can work with a partner or do it on your own. Okay. Give that one a whirl. And remember, you're using the exact same concept each time. Okay, you're identifying the common denominator. You're identifying the common factor. Right? If there's common factors, take out the smallest exponent. Okay. So hopefully that's enough time. Can anybody tell me what the common factor would be? Hmm? Yeah, that's a plus one. So, it's like four. This guy? So that's a common factor as well? No? Right, wrong? Anybody agree? Anybody disagree? Yeah. Sorry. Yeah, I don't know. What do you think? What number is smaller? -3 and -4. Right. Perfect. So -4, -4. So always look for the smallest guy, which is -4. We're all good now? That's the common factor? Yep. Exactly. Because this has a 4, this has an 8, so you can also common factor out of 4. Okay? Make sense? Okay. So again, the same concept, right? But now you're dealing with negative exponents, but the whole concept's the same. Okay. So if I color code it again, my red term, my green term. Out of the red term, I've taken out the 4, so the 4 is gone. I've taken out x minus 3 to the -4, and that's what I had. So that whole thing is gone. I've taken out x plus 1 to the -4, but there was x plus 1 to the -3, right? So x plus 1 to the -4 times x plus 1 to the 1, -4 plus 1 gives me -3, so that's how I end up with a x plus 1 there. Make sense? Okay. Now I'm done with the red term. Green term. I've taken a factor of 4 out of 8, so I'd be left with 2. So I'm left with 2 there. I've taken out x minus 3 to the -4, but there was only -3 of them, so I have to count and put another one there. And this one here, I've taken out all of them. So my final factored expression, 2 times x is 2x, added to x is 3x. 2 times negative 3 is negative 6, added is negative 5. So that would be my final expression. Okay. Any questions on the new type of factor? So what we learned today. So some of you I know haven't had a chance to digest it or even try the questions. Okay. But if you haven't and you want to ask me, again, tomorrow I won't be doing a lesson, right? But you can ask me individually and stuff like that. Okay. So just as a reminder, I just want to go over factoring. I'm not going to go over how to do every single type of factoring, but I want to kind of do that iPhone contact thing in your head, right? A Rolodex used to be a thing people would keep on their desks that rolled and they would have all their contacts on a physical piece of paper, right? That's what it was. You might see it in movies, I don't know. Okay. So the first type of factoring, no matter how many terms you have, is common factoring. No matter what question you're looking at, always look to see if all the terms are common. I don't have to write the word factoring, you know what that means. Okay. If there's common factoring, do your common factoring. Now you have to look at the number of terms. Okay. So the next thing you look at is the number of terms. Okay, so I'm going to write down number of terms. If there's 2 terms, the only thing it can be is difference of squares. So difference of squares would be something like that, a perfect square minus another perfect square, right? Or sum and difference, so either one of cubes. The new stuff that we learned today. So it's either going to be that, or it's going to be that. Those are the only 2 options you're going to have if there's 2 terms. If there's 3 terms, now you're getting into trinomials, right? So trinomials have simple trinomial, which is something like x squared plus bx plus c, right? We look for 2 numbers that multiply to give c and add to give b and put it into brackets. Okay. Complex trinomial, or hard type trinomial. And it gets harder because now there's a number in front of the x squared. And depending on who your teacher was, you would factor that by that cross method or by decomposition. Okay. And then actually with a trinomial now, there's another one called, you can look for, which is called a perfect square trinomial. But it's, if you factor it all, work out anyway. I just want to remind you of a perfect square trinomial. Perfect square trinomial. And a perfect square trinomial is something like this, where you have a perfect square. So I'm just doing an example of it, 4x squared at the beginning, a perfect square at the end, 9, and then the middle term has to be the square root of this guy times the square root of this guy doubled. That's how you identify. Okay? So the square root of this is 2x, square root of this is 3, 2 times 3 is 6, double it. That's a perfect square trinomial. Okay? So hopefully you get to a point where you say, okay, this is a perfect square, this is a perfect square, the square root of this is 2x, the square root of this is 3, that's multiplied 6, double it, it's 12, that works automatically, I know it factors to that. Okay? Because if you can do that, that's going to save you lots of time. If you don't recognize perfect square trinomial, it'll just be a hard type trinomial you'd have to factor it in. Okay? Any questions on that? Okay. If it's 4 terms, then the only thing you can do after common factoring is grouping. right? And there's different types of grouping. You can do a 2 by 2 grouping, or you can do a 3 by 1 grouping, and then you factor. So this is it. Like every single time you see a factoring question, you should be saying, okay, I need to go to my factoring, look for common factoring. No, count the number of terms. There's 2 of them. These are my options. There's 3 of them. These are my options. There's 4 of them. These are my options. Okay? And that's all there is to factor. Just identifying and executing. Any questions you guys want me to go over from factoring? We're good right now? Okay. So I'm going to save this. And like I said, for